Summarizing what we saw previously, velocity of the truck with respect to the road is plus 10 meters per second. Velocity of the car with respect to the road is 0. Velocity of the center mass with respect to the road is 7.5 meters per second. And these three are really all we need, along with some rules to formally analyze the situation. But again, we need to understand these intuitively as well. In any case, and I'll also mention that the whole idea of understanding it formally in terms of equations and formulas, and the understanding that you have when you really grasp and intuitively understand the situation, reinforce one another. So it's not one or the other. You got to be able to use both. Okay, after an inelastic collision, what do you have? Well, the velocity of both is equal to the velocity of the center mass, because they stick together and move off with the velocity, the unchanging velocity of the center of mass. The center of mass is where the two objects are after the collision, since they're together. So they have to move with the velocity of the center of mass. And it follows then that the velocity of both with respect to the center mass is 0. And the velocity of both with respect to the road is 7.5 meters per second. And we could, of course, do that formally. V of both with respect to the road equals velocity of both with respect to the center mass plus the velocity of both with respect to the road. And the velocity of both with respect to the center mass is velocity of the center mass. Sorry, got that wrong. This should be velocity of the center mass with respect to the road. So velocity of both with respect to the center mass, since both are at the center mass, is 0. Velocity of center mass with respect to the road, 7.5 meters per second. Okay, now after an elastic collision, what? Using the prime for the velocity after, V prime of the truck with respect to the center mass, just intuitively, the truck is approaching the center mass. It's catching up to the center mass. The center mass is here. The truck is catching up to it. The truck has a positive velocity with respect to the center of mass. After collision, the center mass is moving away from the truck. The truck is still moving forward, but the center mass is out in front of it. Center mass moving at 2.5 centimeters per second away from the truck. So the truck sees itself receding from the center mass. Truck sees itself after the collision as moving in the negative direction. With the subscripts, we kind of sort that out, but we want to be sure that we think it through intuitively to understand what the solution is telling us. Okay, so the velocity of the truck with respect to the center mass after collision is equal and opposite to the velocity of the truck with respect to the center mass before collision. Basic principle of completely elastic collisions is that the speeds of the two objects with respect to the center mass don't change, but their velocities reverse direction. And then velocity of truck with respect to the center mass before is 2.5 meters per second. The negative of that is negative 2.5 meters per second, which is the intuitively clear conclusion for the after collision velocity of the truck. And similarly with the velocity of the car. Velocity of the car with respect to the center mass before collision is negative 7.5 meters per second. From the center mass, you see the car is approaching you. That reverses upon collision, giving you a velocity of 7.5 meters per second. The car velocity of 7.5 meters per second relative to the center of mass. So again, before collision, from the center of mass, you see the car is approaching you. After collision, you see it as receding from you. In this case, with a positive velocity with respect to the center mass, with respect to your perspective, of 7.5 meters per second. So now the question is, what are these velocities with respect to the road? Well, center mass is still moving at 7.5 meters per second. The truck is receding from it relative to center mass at 2.5, so it's 2.5 meters per second, less than the 7.5, or 5 meters per second. Okay? The car is moving away from it, so center mass is moving this way. The car is moving even faster this way. Don't know if I'm okay. The separation is growing, so the velocity of the car with respect to the road is 7.5 meters per second, in addition to the velocity of the center mass, 15 meters per second. We can go to the subscripts, and we get the same thing. I'm not going to read this to you. It should be clear. And in both cases, we're simply adding the velocity of the truck or the car to the velocity of the center of mass. So that velocity of center mass is 7.5 meters per second in both cases. Velocity of the truck relative to center mass is negative 2.5 meters per second, and that agrees with what the subscripts dictate. Gives us the same result we got up here when we just thought it through. And it can be dangerous to think it through. You always want to check it with the equations. You always want to also check it with the intuition, okay? And here, very similar, we add the 7.5 meters per second to the velocity of the center mass, and we get the same result we got up here.